Welcome to today's experiment. We are the group number 1. We'll be exploring the concept of a forward bias diode and how it allows current to flow in one direction. Additionally, we will use a potentiometer to control the voltage applied to the diode. Let's get started. Before we begin, let's take a look at the components we'll be using. First up would be the diode. It allows current flow in one direction when forward biased. Second would be the variable DC power supply. It provides an adjustable voltage to the circuit. Third would be the resistor. It limits the current to prevent damage to the diode. Fourth up would be the potentiometer, a variable resistor that allows us to control the voltage applied to the diode. Next would be the multimeter. It measures the voltage and the current. And lastly, it would be the breadboard and connecting wires. Now, let's assemble our circuit. Follow these steps to set up the forward bias diode circuit. First up, place the resistor on the breadboard. Second, connect the anode or the positive leg of the diode to one end of the resistor. Third, attach the cathode or the negative leg marked with a stripe to the ground rail of the breadboard. Fourth, connect the positive terminal of the variable power supply to one terminal of the potentiometer. Fifth, connect the middle terminal or the wiper of the potentiometer to the free end of the resistor. Sixth, attach the negative terminal of the power supply to the ground rail. Our circuit is now ready for testing. When the diode is forward biased, it conducts current, allowing electricity to flow through the circuit. Let's observe the diode in action. Switch on the variable power supply and set it initially to 0 volts. Gradually increase the voltage while monitoring the diode's behavior. Adjust the potentiometer to control the voltage applied to the diode. When the voltage reaches around 0.7 for silicon diodes or 0.3 for germanium diodes, the diode will start conducting. If we reverse the diode, it will block the current, demonstrating the principle of forward and reverse biasing. Using the potentiometer, we can fine-tune the voltage across the diode and observe small changes in voltage affect conduction. This is how diodes function in electronic circuits, directing current flow efficiently. Now let's measure voltage across the diode. First, set the multimeter to DC voltage mode. Second, place the positive probe on the anode and the negative probe on the cathode. Third, and last, slowly adjust the potentiometer and power supply to observe how voltage changes across the diode. Okay, now we're done with measuring the voltage. Now let's measure the current. Set the multimeter to DC current mode. Then, connect the multimeter in series with the diode. Lastly, adjust the potentiometer and power supply voltage and observe the current flow when diode is forward biased. These measurements help confirm the behavior of the forward biased diode in a circuit and demonstrate the effect of voltage control using a potentiometer. In this experiment, we built a circuit to test a forward biased diode, observed its ability to conduct current in one direction, and measured its voltage drop and current flow using a variable power supply and potentiometer. The potentiometer allowed us to precisely control the voltage applied to the diode, demonstrating how small voltage adjustments impact its conduction. Understanding diode behavior is crucial for designing circuits like voltage regulators and signal processing devices. Thanks for watching and see you in the next experiment.